Carbohydrates are polyhydroxyaldehydes or ketones. They are classified basically into three categories: monosaccharides, disaccharides, and polysaccharides. Another group is included just above polysaccharide is called as oligosaccharide. We have learned the examples of monosaccharides like glucose, galactose, fructose, ribulose, ribose, erythrose, erythrulose, glyceraldehyde, dihydroxyacetone, so on and so forth. All these monosaccharides are divided into aldose sugar and ketose sugar. The second class of carbohydrates is disaccharide. As the name indicates, when two monosaccharides link together leads to formation of a disaccharide molecule. So these monosaccharides can be among the examples that we have discussed earlier. So they are made up with two monosaccharide units or monomeric units. These two monosaccharide units may be same or they may be different. We'll learn several examples of these disaccharides. These monosaccharides are joined covalently by the linkage or the bond called as glycosidic bond. So the importance of this glycosidic covalent bond is it is important in formation of disaccharide when two monosaccharide units link together. Now we'll see different examples of disaccharides. Before that, you need to practice drawing the structures of monosaccharides in ring form. For example, try to draw a structure of ribose in ring form. Draw structure of glucose in ring form. Draw structure of galactose in ring form, so that you'll be able to draw the structure of a disaccharide. It is a very easy task to understand. Once you understand how to draw the structure of a monosaccharide like glucose, you can easily able to draw structure of a disaccharide. Let us take the first example of a disaccharide, that is maltose. Maltose is a disaccharide that consists of two glucose units. Glucose plus glucose equals to maltose. These two glucose units, here we can see this positive sign, plus sign. This plus sign means it indicates the glycosidic bond. This glycosidic bond is called as alpha 1,4 glycosidic linkage, and this maltose, as it is made up with glucose plus glucose, and between there is a bond, glycosidic bond, called as alpha 1,4 glycosidic bond. Therefore this maltose will be called as glucose alpha 1,4 glucose. So the another name of this maltose. it can be written as glucose alpha 1,4 glucose. So this indicates that maltose is consist of two glucose units, and these two glucose units are linked together by alpha 1,4 linkage. Now we'll understand what is the meaning of this alpha 1,4 linkage. Before that, as I said, you need to draw a complete structure of glucose. Presently, you need to pause this video and take a notebook and draw a structure of glucose in ring form. This is the structure of glucose in ring form as we have discussed earlier. It consists of 6 carbon atoms. Let us count them. Here it is first, second, third, fourth, fifth and sixth. This carbon atom is number 1, surrounded by HOH configuration. Carbon number 2 surrounded by HOH configuration. Carbon number 3 OHH. Carbon number 4 HOH. This is carbon number 5 and carbon number 6 CH2OH. This is carbon number 1, 2, 3, 4, 5 and 6. As we have learned earlier, at carbon number 3, the conformation of HOH or the positions of HOH groups are OH-H. For comparison, you can go back and see the planar structure of glucose. So at carbon number 3, it is OH-H. This is the structure of glucose. Now you see the conformation around carbon number 1 means the position of hydrogen and hydroxyl group around carbon number 1 is HOH. This orientation of hydrogen and hydroxyl ion around this carbon number 1, that is HOH, this conformation is called as alpha conformation. This is called as alpha conformation. So alpha conformation is the conformation around this carbon number 1, it is HOH. It will be called as conformation, that is the arrangement of groups around this central carbon atom, that is called as conformation. If the position is like this, that is OH H around first carbon atom, then the conformation is called as beta conformation. So in case of alpha conformation, it is HOH, and in case of beta conformation, it is OH-H. These conformations are very important in order to understand the type of linkage. Here it is written alpha. That means the conformation around this first carbon atom of the first glucose molecule should be alpha 1 and 4. It indicates the number of carbon atom which are involved in formation of glycosidic bond. So here it indicates that the first carbon In alpha conformation, fourth carbon from other glucose molecule, these first and fourth are involved in the formation of glycosidic bond, and therefore it is called as alpha 1,4. Now draw a structure of glucose. As we have learned, carbon number 1, 2, 3, 4, 5 and 6. You can see this is the conformation which is called as alpha conformation. The type of bond is alpha 1,4. So this is alpha conformation and carbon number 1 is involved, therefore it is alpha 1. Now see the second molecule of glucose. This one. So draw the structure of a second molecule of glucose. You can see here carbon number 1, 2, 3, 4, 5 and 6. So this is carbon number 4, this is carbon number 1. So this is alpha conformation, carbon number 1, and this is carbon number 4, and therefore the linkage will be called as alpha 1,4. This is carbon number 4 of another glucose unit. So you can understand that why the name of this bond is alpha 1,4, alpha conformation, carbon number 1 and carbon number 4. So this HOH group, among this hydroxyl group is involved in the formation of glycosidic bond with this hydroxyl group. So this hydroxyl group from this glucose and this hydroxyl group from first glucose, they are responsible for the formation of a linkage called as glycosidic bond. This one and the hydroxyl groups of these two, OH, OH. So here there will be removal of a water molecule, that means 2 hydrogen atoms and 1 oxygen atom. So there will be removal of HOH, that is H2O. What remains is only 1 oxygen here, and there will be removal of 1 water molecule like this, HOH, and that leads to, so there is removal of water molecule and that leads to formation of glycosidic bond. So this is the glucose molecule where carbon number 1 is at alpha conformation. This is another glucose molecule where the carbon number 4 is this. So these two here, OH, OH and OH, from here H2O will be released to form this glycosidic linkage like this. This is how you can see there is formation of glycosidic linkage where there is removal of one molecule of water. So you can see this HOH. This is glycosidic bond which is present in two glucose units, and this is the structure of maltose, glucose plus glucose. This one glucose unit which is linked to another glucose unit with this bond, and this is another glucose unit. That is how there is formation of maltose when two glucose units are linked together, and this bond is called as alpha 1,4 bond.